Let's now talk about some equipment about this rolling process. The first one is about rolling mills. You see an example here. So it requires actually a high amount of investment, measure investments. They are quite expensive since you need to have several stations to perform these operations on larger workpieces. But obviously, if you are working on small parts, small workpieces, you don't need to invest too much. With less money, you can construct your system and start doing the rolling process. And I can show you an example here. For instance, if you have this much of rolls, then probably it's going to be expensive since in this beginning of the process, the thickness of the workpiece is 2.25 millimeter. And after some number of passes, you see the thickness is reduced to 0.26 and very specific number. So if probably they are using this type of resulting materials in their special applications. And you can see another important here is that if you look at the speeds initially in these rolls, in between these rolls, we have a speed of 2.6 meters per second, but in the last roll, you see the speed is about 30 meters per second. And this is about actually the thickness, since once the thickness is reduced, then due to the again conservation of volume, the speed of material should be a bit higher. And regarding the rolls, I said that we may have some wear on these rolls, so it's better we use stronger and use some stronger materials or select some materials having high resistance to wear. Otherwise, you need to be, again, as in the case of other cutting tools, you need to be frequently changing the rolls. And in some cases, you may apply lubricant so that we will have less friction in between the rolls and the workpiece, and with less power, we can do the process. Now let's have a look at some types of rolling processes. The first one and the most common one is shape rolling. You can see an example here. We can do it at high temperatures or cold temperatures, but mostly it's done in actually cold temperatures. You see, this is the first stage, and we have 6 stages in this shape rolling process. Depending on the complexity of your resulting shape, you may do it in 1 pass, 2 pass, or even as you see 6 passes, maybe more than that. So how we start with such a shape, and then we try to decrease the size of it. In some stages, we use extra rollers from the sides, and at the end, you see we obtain an I-beam. And probably it's obviously the thickness is less compared to the initial workpiece, and the resulting I-beam would have a longer dimension than the initial workpiece. Then we have the second process. This is called as roll forging. You'll see we have an example here. We have rolling process and as well as forging process. And again, we are using rolls, but this time we don't have a continuous contact with the workpiece and the roll. You see, we have weird shapes here. So sometimes we have impact forces on the workpiece. That's why actually we have the term here forging. We will discuss in the next chapter that in the forging process we have impact forces, and we apply it, we have it with the help of these discontinuities on the rolls. Then we have skew rolling. In skew rolling, actually, our main aim is to obtain such spheres. You see, it has the rolls has some special forms, and we feed our workpiece from the side and obtain such semi-finished bolts. And it's a very nice process. And for the bolts actually in the bearings, people use skew rolling. And you may also use another process called, as actually here you see, upsetting. But the problem is that in this process, we have some amount of extra material flash on the side of this ball. So after this one, we need to do some cutting or machining operations to obtain a perfect ball. But in skew bowling, it's not the case. It's almost finished. We may do some little finishing operations, but not obviously machining, or we don't have any extra flashes around the ball. Then we have ring rolling process. As the name implies, we are using this process on the ring shapes. You see, we can decrease the thickness of them with edge rolling, edging rolls, or we can decrease their, say, other thickness with the rounding roll here. And we need to always have a main roll, a driving roll, so that there is some speed and moving over the rolls. And you can see some other shapes which can be obtained with the ring rolling process. The thing is that you need to design these rolls properly, have some weird rolls, and maybe have 6 of them, 8 of them, so that different shapes can be obtained. Then we have another rolling process. It's called as thread rolling. And I think I discussed about this process while we were mentioning about thread machining. So it is an alternative process for thread machining. Instead of opening the threads with machining, you see this is the result of machine threads. But once you do thread rolling, we will have such grains which are actually moving over the surface. So this one has much better strength, compressive strength. So its fatigue life is much better, and you can use this one for a longer time instead of machine threads. So for mass production of bolts, screws, people prefer to use roll threading or thread rolling, and you see their production rate is also high. You can produce about 80 pieces of such bolts in a second. Obviously, if you have proper equipment. And the advantage is that other advantages, you don't have any scraps since you are not removing material, you are not generating chips, and that's why the surfaces are much better. We have smooth surfaces. And as I mentioned, due to the compressive stress actually on the surface, their fatigue life is improved and you can use it for a longer time. We also have the internal version of this process, but a bit complicated. I don't prefer to use this process for the internal threads. This is how it's actually done. We have some different types. You may use some flat dies or similar rollers as we have used in the other rolling processes. But the fundamentals is that you have some actually grooves on your die, on your rolls, so that once you put your blank, let's say, bolt in between and perform a kind of a reciprocating motion, maybe 5 times or 5th time, we can obtain all these threads. As you see, there are different arrangements, but the fundamental idea is the same. We are not removing material, we are shaping the workpiece. Then we have another process. It's called as rotary tube piercing, and it's also sometimes called as -1 process. The guy who invented actually this process. It's about actually obtaining tubes, and we do it with applying some compressive forces or roll forces on the workpiece. And once you actually have a material, have a workpiece, and apply such rolling action, then we will be developing some tensile stresses to the outside of our workpiece. So from some time, after some time, we will have cavities in between, and we use a similar process, the same actual basics in the rotary tube piercing process. And for that purpose, what we do, in order to make things easier, we put a mandrel in between this shape and then try to start the rolling process, and our material will be going through this mandrel, and on this side, we'll obtain a tube shape. But you see on this right-hand side, we have a solid rod. We don't have any opening in between, but once this process is started, a little opening will be increased throughout this, say, process. And the advantage of this process is that we don't have any seams. You don't have any line on the outer surface. We have different piping systems, different piping processes, or tube processes. This one has an advantage over the other ones since it doesn't have any seams on the surface. And we have other variations, but the fundamental is the same. So depending on your requirement, you may have low amount of, let's say, decrease in thickness or high amount, or you may have some several pairs after each other. So this all depends on your requirement on your application. And this is actually the end of the chapter. Make sure that you go through these review questions and maybe qualitative problems.